All right, thanks everyone. My name is Kashif Imran, and I'm a senior solutions architect here in Amazon AI organization. Uh, so I'm going to talk about how you can do customized image and video analysis at scale using Amazon Rekognition. Before I jump into Rekognition, I just want to talk a little bit about AI at AWS. So our mission at AWS is to put machine learning in the hands of every developer. And the way we're making that possible is by providing the broadest and most complete set of machine learning capabilities. If you look at the AI and ML stack at AWS, it's divided in three layers, if you will. So it's a three-layer cake, as sometimes referred to as. The bottom layer is where you get a variety of services and infrastructure options to run a wide variety of machine learning frameworks. So whatever is the right tool for the job, you can run that on AWS, whether it's TensorFlow, MXNet, PyTorch, Gluon, etc. In fact, more than 85% of TensorFlow workloads today run on AWS. The middle layer is what we call is ML services, is where you get a wide variety of services such as SageMaker, which provides tools to run your machine learning lifecycle and provide basically support for machine learning practitioners, data scientists, and developers for end-to-end machine learning journey. The top layer is what we call is AI services. Here at AWS, we get all the data set needed to solve different problems. We then train the machine learning models and deploy them in highly available and highly scalable environment and expose those models using very simple to use APIs and provide a variety of SDKs in different languages such as Java, Node.js, Python, .NET, and so on. So you can easily call those services by just using those SDKs and APIs and build really smart and intelligent applications solving complex business problems. I'm going to focus on the vision, and specifically the service we have there is Amazon Rekognition. So what is Amazon Rekognition? It's a deep learning-based image and video analysis service. So looking at an example here, so for example, you can start as an image, and we'll tell you what is in that image. And there is a variety of other things we send. In this case, things like confidence scores and so on, and we'll jump into talk more about in detail in a minute. So Amazon Rekognition for both image and video provides a wide variety of APIs. So we can do things like object, scene, and activity detection. This is where we have a pre-trained model to detect thousands and thousands of these objects and scene and activities. And today, actually, we're going to focus mostly on custom labels, which then allows you to bring in your custom objects, the things that you want to detect for specific to your business. Rekognition provides a content moderation API, so you can detect, for example, if the content is safe for your audience and not. So things like explicit, suggestive content, violent content, and so on. Rekognition provides capabilities to do face detection and analysis, as well as face search. We provide an API to do celebrity recognition, where we have hundreds and thousands of celebrities. So you can just send an image or video, and we can recognize those celebrities in those. Rekognition has a detect text API, so you can detect text in the images and videos, for example. Similarly, there's support for live streaming video as well as pathing API and so on. So let me just quickly jump to the AWS console and kind of show you quickly how some of these features look like. So here I'm in Amazon Rekognition console in AWS. So in the console, let me click on object and scene detection. So in this case, you can see we have this sample image, and as we call Rekognition, it returns a list of objects it detected, as well as scene information. So we call this Labels API. So it's returning you a list of these labels that it detected. And for each one of the labels, it also returns the confidence score. So depending on the application, then you can set certain threshold on what is that acceptable for your specific business use case. In some cases, it could be 95% or 80% and so on. For many of these objects, we also return bounding box. So for example, in this case, you can see we're putting a bounding box that there is a person. And then we have bounding box around objects like cars and so on. And you can build very interesting applications using Lables API. So for example, customers are using it to do things like media analysis, where you can get more information out of those images and build a search library to find relevant content. We have another demo, an example that shows how you can use, for example, in the worker safety space, by detecting things like hard hat and people, you can kind of do an auditing whether people at a construction site, for example, if they are wearing safety gear, the hard hat and so on or not. It could be used in zones maybe where there shouldn't be a person, maybe again at a construction site, and by detecting that there is a person maybe who shouldn't be there, you can generate some alert and so on. So there is a wide variety of interesting applications that you can build just by detecting different objects and seeing in the images and in the video. Let's look at an image moderation API. So both in this case, image or video, you can see. So in this case, we found there is no offensive object, whereas there is another image. In this case, when we call Rekognition, it returns us that there is suggestive content. So in this case, the API doesn't tell you just safe or unsafe, because safe or unsafe really depends on the region where you are providing that application. So maybe some content which may not be offensive, in one part of the world, it might be considered offensive in another part of the world. So we return a hierarchy of these labels that we detect, and then based on, as a developer, then you have the control based on those that what you define is safe or not safe for your audience. Rekognition can do things like facial analysis. So you can see in this case, it can detect there is a person. There are things like age range and a lot of other details about different facial attributes. Let's look at another example API. So this is the celebrity API. So again, when you send an image or video, it can detect the celebrity and return the confidence score and so on. It provides a face comparison API. So in this case, you can compare, for example, different images, and it provides you a similarity score in those images. And then at last, the text API. So again, in this case, we have an image, and we return all the words as well as combine those into lines, so you can extract that text. So there is customers are using again these APIs in very interesting ways. We have a customer, for example, who is using text API to do text extraction from the pictures of marathon. So for example, if you are running a marathon and you want to go back and see all the pictures that you were in, they can just extract text from the runner's bibs and then index those pictures accordingly. So you just search by your bib number, and then you're able to find the relevant pictures from the marathon. Similar to these image APIs, we have video API for across all of these, whether it's label and object and scene detection or moderation or facial analysis and text and so on. So in this case, you can see we have a sample image, and we can kind of switch. So it's telling us, there are different people in the image. We can switch to celebrity view. So it tells us different celebrities as well as, different objects that it detected. Now let me switch. So this is how, it looks like in console. Let me switch to my a code example here and just show you how easy it is to use something like this, these APIs using SDK. So in this case, I have an example. So I have a sample image in my S3 bucket, and we want to call that image and analyze using, so in this case, I have a Python sample. So you see in just in few lines, so here is my example image in my S3 bucket. All we do is initialize a client, and then we can call detect labels API. So this is the API which returns different objects and scene and so on, and we pass it the object. We tell it that we only want up to 10 labels, and we only want labels if the confidence score is above 60%. We get the response back, which is just simple JSON. We iterate through JSON and then just print those labels. So let me go ahead and run this example. So this is the same image that we use for skateboard that I showed earlier in the console. So you can see we're getting different labels like vehicle, car, person, and so on. So you can see it's very, very simple to use, just few lines of code, and you're able to process content using a Rekognition. All right. So this was a very, very quick overview of how different APIs across Rekognition work. We have large number of AWS customers who are taking advantage of Rekognition to build applications across different verticals and industries, whether it's media and entertainment, public safety, and all in industry, and so on. Today, I want to focus on the next topic is basically custom labels, which was one of the most common customer requests. So as I mentioned, the Lables API is where we train the models and we detect thousands of different objects. But the most common request we got from customers was that Lables API is not specific enough for my specific business needs. So for example, if you have an image like this and you call Rekognition, you get something back as a machine part. Similarly, you get machine parts for these images. But it will be a lot more interesting, and you can build very interesting applications if you can specifically detect that this is a turbocharger, or this is a torque converter, or this is a crankshaft. Similarly, if you send this example to Rekognition today, you get something back like logos and icons and symbol, which is correct. But it'll be more interesting and enable many other use cases if you can get things like, the logo is for EC2 or S3 or Rekognition and so on. There's another example. So if you have an image like this, you send it to Rekognition Lables API, you get something like comic or cartoons, but it'll be more interesting to get and detect that there are specific characters, and this is Arthur and Buster in this. Here is another example image. So again, if you send it to Rekognition, it returns you labels like leaves, which is again correct. But many customers would want whether this is a damaged leaves, or this is infected, or these are healthy leaves, and so on. So if you want to basically do that object detection for your specific business objects, then the choice you have is either do it yourself, which means you need to have deep learning expertise, which are hard to find. You also need tens and thousands of labeled images, which can again be time consuming. And then it means, it can take several weeks to months before you have a finished product. Or you could just do this manually, which again is very, can be time consuming, especially if you're doing it at scale and error prone. So that's why many customers end up just not doing it manually, or try to have, scalable option where then they have to build the custom models and so on. And that's where Rekognition custom labels come in. So Amazon Rekognition custom labels allows you to have customized image analysis to easily detect objects and scenes which are relevant to your specific business. So it gives you guided experience to create labeled data sets. You can then train and evaluate the images, your machine learning models. And the cool part is it does not require any machine learning experience, and even without any coding. So you will see pretty quickly, how you can get to a point where you have working model without any ML experience or even writing a single line of code. Once you have the model, you can just deploy that, and then you can use very simple to use API to take advantage of that model. So instead of getting generic labels like machine part, you're able to get specific images like turbocharger, torque converter, crankshaft, and so on. So let's jump into a demo and show you how Amazon Rekognition custom labels work. For the demo, what we're going to show you is, so here is a funny clip from Blender Foundation. So let's say if you have taken an image like this, you get some image labels today from the Lables API, which are accurate. But what we want to do is we would like to detect these specific characters with their name. So this is the process that I'm going to walk you through. So these are the steps that you will take to solve any problem using custom labels. This is what we're going to use for this demo, but it applies to any other model that you want to build. So the first step is the problem that you want to solve. You need to collect images, whatever that object that you want to detect. Once you have sample images that you want to detect, you will go ahead and create a training set and a test set. So a training set is what Rekognition custom labels will use to train the model, and test set is what it will use to then evaluate the model. We will then go ahead and train the model, and then provide you evaluation results, which you'll be able to see how the model is performing. And if it works based on the criteria you have for your business use case, then you can go ahead and use that model. So let me go ahead and show you all these steps. So in the Rekognition console, let me switch to custom labels. So as I mentioned, the first step is we need to get images. So let me show you images that we have. So I have a couple of images for each one of the objects we want to detect in my S3 bucket, and I have grouped those by each character. So the character Frank, I have a couple of images for Frank, a couple of images for Rinky, and so on. So we need to go ahead and create a data set for these animated characters first. So let's go to Rekognition custom labels. Let me go to data set, and let me create a data set. So we'll call it Big Buck Bunny. Just gonna give it some interesting name because I have created a couple of data sets with similar names. So here you get a couple of options to bring your images into custom labels. So you can, for example, upload images directly from your machine. You can import images from an S3 bucket. You can import images from, if you're already using something like SageMaker Ground Truth. So SageMaker Ground Truth is a service which allows you to annotate your images at scale. So if many customers are already using that, so you can just easily import from there. Or if you already have an existing data set in custom labels that you created earlier and you want to clone that, then you can just use that option as well. I'm going to go ahead, since my images, I put them in an S3 bucket. I'm just going to go ahead and use that option. So it asks me the path. So I'm going to go ahead and pass the URL to where my images are. And here I can select this checkbox for automatic labeling. The idea here is as you import these images, since I group them into folders, Rekognition custom labels is going to use those folder names as labels and automatically annotate my data set. So I don't have to go and label all those images myself. It's automatically going to do that for me. Here is a policy that you need to have on your S3 bucket. So Rekognition custom labels can go ahead and get those images. You just pretty much copy it and then paste it in the S3 for your S3 bucket. I've already done that, so I'm just going to go ahead and hit submit. And here in a few seconds, you see I have my data set and the images that I have from my S3 bucket are showing up here. In this case, you can see it automatically created all the labels based on the folder names and automatically labeled my images for those labels. You can see I have total 9 images, 8 are labeled, 1 is not labeled, because if you notice in my S3 bucket, I had 1 image which was not part of any folder. So I just wanted to show you how if you organize them in folders, it's very easy and automatically get labeled. So once you have content in, let me show you how you can further, for example, if you want to detect bounding boxes, so where each character is, we can click on Start Labeling. And just to save some time, I'm only going to select, let's say, just do the first and last, and we'll call it, let's use the Draw Bounding Boxes. So in this case, you get this guided experience where you can, so I can then click the label, draw a bounding box on this one, draw a bounding box on this character, draw on Frank, click next. For the next image, let's select Big Buck Bunny, draw on that, and hit done. And then we can save changes. So you can see pretty quickly, I'm able to bring in images that I need to train the model to detect these specific characters, label them, draw bounding boxes, and so on. And now we have the data set. Once you have the data set, we can go to projects and click on create project. So project is a container for anything you're doing. So as you create different versions of a model, they will all be within a project. So let me just call it Big Buck Project. Click Create Project. And then you just click on Train New Model. Here, the custom labels ask you for two things. It needs a training data set, and then it needs a test data set. So in case of test data set, training data set, we can, here is our data set. For test, you can either prepare a completely separate data set and then assign that, or you could just ask custom labels to do a split. So for example, it can just do a 20-80 split. So 80% of the images in the data set are used for training, and then 20% of the images are used to evaluate the model. And then you can just hit train. It can take a little bit of time to train the model. So let me just cancel out of this because this is the last screen and show you an existing model that I've already trained. So here, I have a model that I already trained. And so once the model is trained, basically this is what the experience looks like. It gives you, here is a specific version that you have trained. If I go to the details, these are the kind of details you get for the model. So you get evaluation results. So based on the test data set that you provided, we calculate things like average precision, overall recall, things like F1 score to give you an idea of how your model is performing. And not just at the model level, it also provides you performance for each individual label. So based on that, then you can see how each individual label that you're interested in, how it's performing, and if there is, for example, in this case, maybe there is some issue with precision, it's 85%. So there are maybe some steps that we need to take for this specific label and so on. Let me click on view test results. So this is where we give you a visual, basically a summary of how things are. So in this case, you can see for each image, how many true positive, false positives, and all of that. So again, kind of quickly reviewing this gives you an idea how your model is performing. And if you need to bring in maybe more images, or if there is any data quality issues in your data set and so on, you are able to quickly spot those. Now with the model trained, how do you use that? So there are a couple of ways, and we'll talk about API and some of the CLI options in a second. But this is your specific model, so you get a custom ARN for that model. To use that, we have a demo application that you can use. And again, this is available on the AWS samples GitHub repo. So it's a pretty simple CloudFormation template, just next few steps, and you get this UI running. Here, this is the model that I was just showing you. So let me go to that model, and let me select an example image here. And you can see in this case, now we're able to detect these specific characters with their names instead of just some generic labels that I showed you earlier in the slide deck. Let me take another example image. And again, you can see in this case, we are detecting these specific animated characters. So this is how it looks in the console. Let me switch back to API and show you what the API looks like. And then I'll show you an example of how you can programmatically do the same thing. So Amazon custom labels have a very simple API. So the things that you saw where I created a project and so on, you have an API for each one of those. So create project allows you to create a project. Describe projects gives you a list of projects back. Apologies, for some reason, it's just clicking next. All right, the create project version is the one that trains the model. So you saw in the console, I clicked on train model. Behind the scene, basically it's using the create project version API. Describe a project version returns the list of all the models in your project. And then once your model is trained, you can use start project version to start it and stop project version to stop using it. To do the inference, you just call the detect custom labels API, which then you can send an image and it can detect the objects and return the list of objects as JSON. This is very simple, just very similar to labels API that I showed earlier. So you basically, once the model is trained, you can tell it how many returns you want, what is the minimum confidence score, and the image that you want to process. So let me switch to another example and show you how you programmatically do this. So here I have custom labels example. So again, we have the sample image we just saw earlier. It's in an S3 bucket. And here is the product version ARN for my specific project. I can go ahead and create a recognition client and then call detect custom labels API, and then get the results back. So let me go ahead and call the custom labels. So in this case, you can see we get the characters back. Another example question usually I get is how can I process then video with this? So here I have a video example, and I'll go ahead and run this while it's running. I'll explain what it does. So you can use something like OpenCV or any of the library to just extract individual frames from the video. So in this case, that's exactly what we're doing. So using OpenCV, we basically get the frames. If we found a frame, we get it. And then you can basically call same detect custom labels API, pass it that frame as an image, and tell it which specific project that you want to run it against. You get the response back as JSON, and then we can just put that, in this case, we're putting it in a JSON file. So you can see in this case, I have a small clip, a few seconds, and we detected some characters. So let me go ahead and open that JSON. So you can see we detected the characters with confidence score and the bounding box, and it's telling us at which timestamp. So at time 1 second, it found a character, and so on. So it is that simple to basically train a custom model for your specific business objects, and then use either a console demo app that I showed you, or using APIs to then process your images as well as videos. We only have a minute left, so I'll just wrap up by just highlighting a few things how we kind of do this behind the scene. So under the hood, we have tons of machine learning models that we have pre-trained. So as you provide us your data set and training set, based on those, we select a couple of models. We then optimize and train them based on your data set, choose the best performing model, and that's how you get your specific custom model. And whether you have use cases around classification, for example, or you have things like localization, you could do any of those. Just last few things about how do you build a high performing model. So again, in this case, we give you all the tools, as I mentioned, looking at things like how the model is performing based on the evaluation summary. You kind of get the ideas there, whether there is false positive, false negatives, and so on. And then based on that, you can optimize things. If, for example, whether you need to increase the data set size, or you need to maybe fix some quality issues with your labels, or if you need to either bring bounding boxes or more labels and so on. To wrap up, the custom labels, the idea is you're able to customize it for your business needs. You don't need any machine learning experience to build machine learning models. We provide intuitive UI, so without writing any code, you can finish end to end. A lot less training data is required. So instead of tens to hundreds of images, you only need, instead of tens of thousands, you only need tens to hundreds of images. And you can build the model within a few hours, and it's all managed by AWS. That's all I had, so thank you.